when we switch this button, we can see now it's too fast to see, and we actually have to use our oscilloscope to see that we are running the clock at 1 megahertz. Welcome back to another episode of the Breadboard Apprentice. In the last 2 episodes we started building the clock module, and we added 2 different modes. The variable frequency mode using a 555 timer, and the push button that generated single pulses for us. The variable frequency mode will be especially useful for us when we are actually building out the other modules for our computer, since it will be able to trace out what the modules are doing at any given time. So we will call this mode trace mode from now on. And when we need extra slow speed or manual control, we can use the push button to step single instructions at a time. So we will call this the manual mode from now on. But at some point we also want to test the full capability of each module, and therefore we would need to add a high frequency mode or an oscillator to run at a high speed. And that's what we're gonna do in today's episode. So in the last episode we connected this push button and we properly debounced it, and as you can see it still works fine with no bounces either on the push or on the release. However, now to continue, I thought that we could actually move this push button circuit up to the breadboard here together with our variable frequency mode. And I also want to be adding in the high frequency mode, or this oscillator, which is an oscillator of 1 megahertz. And hopefully our computer build is gonna be stable enough so that we can run this whole computer at 1 megahertz, and that would be really cool if we could do that. So let's get to reorient this board. I started by removing the push button with all the circuitry going into debouncing the push button. Then I moved on by placing the different components in relations to one another to figure out roughly how I wanted the layout of the circuit. I figured it would be better to group the variable frequency mode and the oscillator close together. That would also allow to have some distance between the push button and the potentiometer. I'm not sure whether or not that matters in the end, but anyways, that's how I thought about it. For the other ICs, the Schmitt trigger inverter and the selector and the NOT gates, I knew I wanted to group those together as well. And for the toggle switches, those I really wanted on the end of the breadboard. But with all the ICs and the 3 different clock modes on the board, there was no more room at the end of the breadboard. Therefore, I had to again reorient and compactify the whole layout. In the end, I spent way more time than I originally planned to make this circuit compact enough for all of the components to fit onto one breadboard. But in the end the result was really nice, and I'm really pleased with the layout as it turned out. To handle this selection, we are using the 74 HTC 153. And we connect the single pulse input from the push button at C3 and C1. Then we connect our variable frequency mode or trace mode to C0. And we connect the high frequency or run mode to C2. And to make the selection, we connect the two toggle switches to A and B inputs. We need to activate our output by setting G1 to ground since it's active low. And just to be sure, we are setting G2 high, meaning that part of the IC will be disconnected. As we learned in the last episode, physical switches usually have some bounce to them, and toggle switches are no different. But with toggle switches we can use a far more convenient way to debounce them than using an RC network. We can use this sort of circuit where we take advantage of the properties of an SR latch, which have some memory that stores what state the switch was in the previous. So even though it bounces, it will not affect the output of the SR latch. And for the physical layout, this is how we used a quad NAND gate to create two SR latches. I'm only showing you one of the SR latches here. It is completely the same on the other side. What's important to note here, and that I struggled with for a while when I was building this SR latch and connecting the toggle switches, is that both sides of the toggle switch need to be connected. So one for the set pin and the other for the reset pin. So when you're toggling back and forth, you're actually switching back and forth. And I didn't notice that at the start, and I was not able to set or reset the SR latch at first. So there we have it. I am beyond pleased that we managed to get all the components to the top breadboard. And as we can see now, it is in trace mode and just counting slowly. And if we are switching this, we go into manual mode, and we can, just as before, manually switch. And if we turn it back to trace mode and now switched on the run mode, then we see all of a sudden we are not able to see this with our naked eyes because the 1 megahertz clock frequency is way too high for us to see. But let me start the oscilloscope so that you can actually see that I'm not fooling you. We are actually running at 1 megahertz. It will just take some time to start. I don't want to start the oscilloscope before we are actually needing it. when we are doing the recordings, because it's quite noisy. There we go. And if I now increase the, and here we see that we are, let me just change the vertical sync as well, or vertical time intervals, or horizontal time intervals. That's okay. And now we can see our pulse width is exactly 1 microsecond, which corresponds to 1 megahertz. And now, just to see, we can switch back to trace mode, and we see this lower pulse again. And in fact, now we have to zoom way out. And in fact, it's so slow we cannot properly trigger on this pulse. But it is right now about 1 second. Or about 2 seconds. Okay. There are some things that I do not like with the way that we have created it now. And first off, I don't really like that we use 2 toggle switches. It feels a bit unnecessary. And in fact, I have these kind of toggle switches, which is on, off and on. And so they have 3 different positions. And since we only have 3 different modes to run our clock, I would much rather prefer to use one of these switches. So I will see if I can come up with a circuit to actually utilize this instead. I believe that I will not be able to actually use the SR latches in this configuration, but actually that I will need to come up with another way to do it. And what I don't like either is these LEDs that I have. I would actually much more like to have LEDs that indicate each of the different modes. So not only when we are in stop or manual mode, because now if I switch, the other one will turn on as well, and we will see a run button. So which is it? Is it manual or is it run? That I do not like. And perhaps with the other toggle switch, that is the 3 different states, we will be able to change this as well. But overall, I am very pleased how this clock circuit turned out. That is unfortunately all that we have time for in today's episode. But we have come quite far in the build of our clock module. All that is really left now is to transfer this design to a schematic, and to also send that schematic off to a PCB manufacturer. And that is what we will start looking into in the next episode. So I hope you join me for that as well. Bye!